All right. Hey guys, looks like I'm going live now. Welcome to Ferris Makes Emulators. I guess this is the fourth episode. I think I called it All the Instructions Part 2. First of all, I gotta apologize. I just realized that I totally forgot my laptop charger at work, and that's a bit far away. So we might have to cut it a bit short tonight, but I think I'm going to try to also stream tomorrow night at around the same time, maybe a bit earlier, so we'll try to make up for that. I'm also still a bit jet lagged from traveling, so if I'm a bit groggy and slow today, sorry about that. Yeah, this should be pretty fun. So as usual, the first thing I want to go over is some sort of changes to the project since we were last on stream. I don't like to, of course, accept a lot of I don't want to actually write any code when I'm not on the stream. So you won't really see me do that. But I have been doing some stuff with the README and some updates there. And some people have submitted some pull requests that I've accepted and also some that I've deferred until the start of the stream. So I want to go over those. New School says no sound. I'm pretty sure I'm broadcasting sound. Someone can double check on that. Daniel Collins, sound works here. Okay. Sorry, New School. Tomix, hi, first time watching live. Hey there. Yeah. So, so the first thing I actually wanted to go over is some stuff that I already accepted. Carrie Ann added some, he cleaned up the datasheet URL in the README, so thanks for that. Ryan Hebert added some Travis configuration stuff, which is awesome. So now, if people are going to fork this and give me a pull request, and I'll get to some things that I have to say about that in a second, then we can actually get testing on that, which is pretty nice. Then Emun, or Daniel Collin in the chat over here, also added AppVer support, which is pretty cool. So our tests are run now on Linux and Mac and Windows, which is really great. I think that's everything that I actually accepted. Beyond that, I think I just did some cleanup on the README. Oh yeah, one more thing. Ryan Hebert also added this this pretty awesome logo here. This Prostendo 64 logo. So I guess this is officially a thing now. So that's pretty cool. Nusan says hi. Hey there. Yeah. Okay, so that was sort of the stuff that I already accepted. Another thing that I wanted to say about sort of pull requests and stuff is that I started getting some pull requests that were kind of large. And now I really appreciate that you guys are getting super stoked on the project. I think that's awesome. And I love that you guys want to help. But I kind of wanted to remind everyone that the point of doing this project is sort of documenting everything by live coding it. And if we sort of start accepting PRs that are, sort of larger chunks of code, then we totally miss out on the whole experience of having watched, the thought process and the documentation that code would have come from. So I kind of just want to keep it to small, isolated things that I can go over on the stream, and otherwise I'll have to reject it. But it hasn't really been a problem yet. We had a couple pull requests that, just talked to the guys, and they were really friendly, and they totally understood, and yeah, it's just been really positive. So that's cool. Yeah. Next thing is the actual pull requests that are remaining that I wanted to accept on the stream. I wanted to go over that. Birkenfeld, hey there. Great. Yeah, so the first one I wanted to go over is number 7, make module imports nicer with pub use. So this was a pretty nice one, actually. It was just about let me look at this again, refresh my memory. But the whole idea is that there were certain modules that we had, here, use super CPU. We had the whole CPU module being public and all this stuff in this module being public, and it was just about sort of refining what we actually want to expose from the different modules. So it's literally like a 5-line fix, but it actually cleans up a lot of sort of visibility stuff that was pretty nice. So I'll just push the button on that really quick. merge. So there's one down. So that was from Birkenfeld, so shout outs to him for that. It's pretty cool. This next one, number 8, was also from Birkenfeld. This is use wrapping add for load address offset. So I want to actually look at the code for this one and bring that up. We can just look at the files changed. So this is when we were, let me actually look up the specific instruction that was for. 1 second. Yeah, this was here. We were implementing load word. I think that was the last instruction we got to. And so we were calculating the specific address, and we did some stuff where we took this offset that came from the instruction decoding that was like a signed 16-bit value, and then we sign extended it as U64, and then we would add that to whatever this register value was. The problem with that is that Rust, at least in debug builds and under some other circumstances that depend on quite a lot of things, if a number like this is or if two large numbers like this are added together and they end up overflowing, normally, or sort of what we expect to happen here is that it'll just overflow and be fine, and it'll just wrap around, and that's kind of what we want. Because when we sign extend a value like this as a U64, because of 2's complement, when we start adding things, we actually do want it to be effectively a subtract. And this will actually panic in some configurations as it currently is. And so using wrapping add is just a method from the Rust standard library that basically is just the same thing as an add without those checks. So what you're basically encoding here is specifically, I want this to add, and I want it to be okay if it's wrapping. So all that was just changing this add here to a wrapping add. So it's super helpful though, so thanks to Birkenfeld for that. Checking the chat a bit. Crazy92, in before half of these need to be rebased now and can't be merged. I actually think we'll be okay with that because they should all be pretty small. Yeah, so this was the wrapping adds one. Go ahead and merge that. Good stuff. 2 down, 3 to go. So Tristan117 implemented pretty printing for CPU general purpose and floating point registers. Long name, but pretty simple thing. So as we were running the stuff in the terminal here, we would be printing out the whole CPU state like this. And for instance, this list of registers is just like, this is not a really good way to visualize this. It's basically just pretty printing for all this stuff, which is going to be really helpful as we move forward and implement more of these instructions. All the data that he got from that is data that we had seen before on the stream. So like what the different names of these registers would be, their aliases, also just printing them as hex values, which is going to be really helpful. Other such things. I think there's a couple more details with it in there. But yeah, I mean, it's really just pretty printing for stuff that we've already seen on the stream before. So fairly straightforward. So I wanted to accept that just because that'll be really helpful. Scroll way down and merge. Looks like it worked. All right, 3 down, 2 to go. Yes, another one. Simon Nichols wanted to add some Linux and Windows alternatives to Dash for documentation. So on our README here, I listed under helpful tools this Dash tool, which is this basically documentation browser that's really quite nice. And so he wanted to post some like alternatives for Linux and Windows because that tool's OSS only. So we made sure that they were ones that the Dash author was happy with and recommending on his own site. So cool stuff. So I want to just merge that. Just a quick README update. Last but not least, VGTurtle127 add links to legal ROMs and also remove to do. So this was actually really cool. VGTurtle, I guess, is a contributor to a bunch of other N64 emulators, and he's quite knowledgeable about where you can actually get a lot of public domain ROMs. that include various test ROMs, various like graphics demos, and those kind of things. So he just wanted to add a bunch of these links to those, and just trying to stay away from all the sketchy sites where you don't really want to be getting ROMs from. Just keep everything nice and clean. So that was really cool. I think he's also in the process of putting together a repo where a lot of these public domain ROMs can be found in one place. Again, to avoid all these sketchy sites that I won't mention by name. So just to sort of clean that whole situation up. So again, just a nice little README change, but pretty helpful. So shout outs to him for that. It's pretty awesome. And I believe that is all the pull requests. And none of them had to be rebased, which is pretty nice. So yeah, with that, I think we can start continuing where we left off. Let's do a quick git pull. Looks like we're okay. And run everything, and we are still, yeah. So where we're basically at is we have, we're still working on the CPU and just basically getting through the boot ROM. Let's see, I forgot to look at the online disassembler. Let me pull that up really quick. And I'll also open up that boot ROM. Let's copy a bunch of this. Get our online disassembler. Paste it over there. I'll bring it over to the proper screen in a second. Whoa. Get our big Indian MIPS on. MIPS 4300 and big Indian. There we go. There's the flavor. Yeah, so how far did we get? I don't remember exactly, but I believe it was this load word instruction here. Because I believe we were actually loading a word from where this is, yeah, A.004, which matches up with our A.004, I believe. My face is in the way of that. There we go. Yeah, so what's happening now is that we've gotten through a bunch of these instructions here. These first couple loads and storing in these coprocessor registers, which is really cool. And now we're getting to this point where we're, I guess, starting to talk to the peripherals. Because if I remember correctly, we're going to be loading a word, I guess, into this T0 register from this place, which is going to be this big old address. And I believe if we looked at the memory map, then that was going to be one of the reality signal processor registers. So let me go ahead and pull up the memory map. I'll go through our repos documentation stuff. Where is it? Detailed N64 memory map. Here is a lovely little memory map. We were looking at, which address was this? Yeah, 234, so 0404. That basically starts. And that is this range, it looks like. Yeah. Oh, this is SP registers. Okay, so I may have been, I think SP is the bus that goes between the CPU and the signal processor, or maybe it's just the signal processor. I don't really know that. Let me start looking that up, I guess. Google around for that. SP. I cannot remember. Actually, you know what? This would be a really good time to start pulling up an N64 dev repo that I believe came from Mike Ryan. this one. Yeah, so I believe I mentioned this on one of the previous streams. This was this N64 dev repo from Mike Ryan, which just has a bunch of open source stuff for developing N64 things. In particular, I want to look in the docs section because we really want to find out what this SP was. I don't think this memory map is going to tell us because I think it's just going to tell us where things are. Although, we could actually also search 0404 and probably find where some of this is. SPMem add reg. There's a master SP memory address. Interesting. I'm wondering, actually, because what this looks like to me, almost, is that this is 0404 0000 to 0404 0003, and we were actually at 0404 0010. Where is that? That's a bit higher here. What I was going to say about this range is that I wonder if actually these devices will communicate, like you send some registers so that they both will look at, or that the peripheral will actually look at a certain chunk of memory that you can actually interface with it there. Anyway, I believe they all share the same memory, but I could be talking nonsense. The extra peripherals probably have their own internal memory that's probably quite fast. Actually, I can almost guarantee that the display processor will. 0404 0010 here. So these are status registers. So this actually makes a lot of sense. So it looks like we're reading from the SP status register. I'm just going to Google SP status register with N64. Also, I want to search in this N64 dev repo for SP status reg. And the reason why I want to do that is I just want to kind of find out what that's meant to be. And I don't really know, I'm not very familiar with a lot of these docs yet, or especially not what a lot of these registers are, so I'm just going to be kind of looking around for that. Ooh, interesting. I guess this is a Nintendo 64 assembler tutorial. Well, that's kind of fun. So so here it goes over the SP registers. Okay, actually, let's look at this. First, read N64 ops h.txt. By the way, that's totally in this N64 dev repo. In fact, I believe it was here. This one. N64 ops #h.txt. Okay, so that's the memory map. That's basically what we're looking at here. Well, that doesn't seem to be terribly important unless it says the SP registers are. It might just be that they're just the RSP registers and they just call them SP for some reason. Signal processor would make sense. SP base reg. DMEM, IMEM, I guess those are. Oh. I'm not really sure what those are yet. SPMem matter. Looks like you have some DMA. That's fun. You would need it. Yeah, so this status register, it looks like it's 0 to 3. So that would be 32 bits wide, but it looks like we only go up to 24. But I guess if we're going to be reading whole words from that, then that makes sense. So since we're reading it, I don't know which bits of these it will actually use. But I'm guessing we can start basically filling a lot of these with dummy values if we're just going to return a value from this. It's probably not halted. It's probably not broke, whatever that means. The DMA is probably not busy. DMA is probably not full. IO is probably not full. Who knows what single step is? I'll have to figure that out. Interrupt on break, also don't really know what that is. And then signals 0 through 7, I wonder what those are. Doesn't say much down here in the memory map, at least. Probably just going to have to find that information elsewhere. But let's actually start reading through this N64 ASM thing, because this actually looks pretty cool. So first read this and look at the SP register section. So I believe that's what this was. Probably just getting us familiar with the names of things. RSP is like another processor and contains most of the instructions of the main R4300i. The RSP can only address main memory from A4 blah 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 to A4 lots of Fs. If you want to access other parts of memory, you have to use the SP memory. Registers to DMA to other parts of main memory. You probably have to use the SP memory registers to DMA to other parts of main memory. Conveniently, the SP registers reside in the part of main memory that the RSP can access. There are two sections of the RSP's memory that are for data and code respectively. One is DMEM that stores the data, and it is at these ranges of addresses, not very big. The other is IMEM and stores code for the RSP to execute, and that is at these other addresses. Okay, so cool. So we're already sort of learning what that is. Daniel Collins says single step may be debug support. I don't know. Yeah, that actually could make sense. I mean, it's kind of hard to imagine that it would have that sort of any kind of debug support, even if it's that rudimentary, but I probably lack a lot of details to how that would work, so probably not my call. The SP registers, the RSP memory registers start at this, which is where we're reading from, and these aren't in order and are only the ones we are going to need today. Interesting. Hopefully this has, yeah, okay, so I just skipped all these because I just want to look at the one that we're actually going to be reading, which looks like this SP status reg. This allows you to set breaks and halts and interrupts and stuff. Okay, so breaks and halts are also probably debugging stuff. You need to clear a bunch of that stuff in this register to start the RSP. Crazy92, Rosendo should have a GDB server. Actually, if I'm going to be running any of those servers, the first one I want to look at is Daniel Collins' Pro DBG, just because it seems really cool. But I believe there's some Mac-specific bugs that haven't been fixed in there yet. Hint, hint, cough, cough. Yeah, so it looks like this assembler tutorial, which is going to be pretty cool. I'm actually going to post a link to this in the chat, by the way. This actually looks really useful. So this will, I guess, give us a process for setting up the DMA here. Or actually, I wonder if that's related to actually making this go. This is what it says here. So let's see what the assembler's doing. And I can't remember with MIPS assembler, is it the source and then target, or the target and the source? Let me look that up. Oops, quick tutorial, that might help. Just give me the... Yeah, okay, destination first, source later. Good to know. Yeah, so in this case, if your LA, I guess, is like load from address, that's probably what this is. So we're loading T0 with the value of this. So what's happening here is, I guess it's reading the value into T0 here. Yeah, no, that's T0. I was thinking register 0 again. Which is the fatal mistake I made in episode 2. So it looks like it's loading that with this value. Load immediate with some stuff that I guess it's going to flip. And SW is probably store word. There's SW. Yeah, that's what that was. And interestingly enough, you write where it's going to be stored after this. I guess that makes the assembler look nice. Amplify says there's some bit in the status register of the SP which is a semaphore, if I recall correctly, which does some mutex stuff when you read or set it. Interesting. Very interesting. Yeah, it does. It actually looks like there's down here 0404 001C that there's actually a semaphore register. I wonder if that's what you're thinking of. Cool though. That's actually fairly interesting. So I like this section making the RSP go. Set SP PC register. PC is probably program counter. Yeah, program counter for RSP can set it to 0. Because I guess that's 0 within the instruction memory that the RSP has. So you just execute from the beginning of that upwards. Then you set SP status register. You need to clear almost everything that can be cleared in the first 9 bits, and then see this. After you clear the halts and breaks and stuff, the RSP will start running its code. So that's pretty cool for when we actually start writing that register. When we start reading from it, again, I'm not really sure how this is a lot of this stuff is gonna work, but I don't know. My gut feeling is that we can start returning dummy data and then just sort of fill the rest in when we need to. The RSP is gonna be a fairly difficult peripheral to properly emulate, I understand. It's going to be a fun one, but it's going to be a tough one, I think. So I think just starting to return some dummy values and just trying to get farther with the boot ROM is, I think, our best option here. Yeah, so let's just do that. Let's dig into the code, see if I remember where everything is after a week and a half, which is going to be impressive for me. So our error was nice physical address. That would have been in the interconnect. Yeah, so that's coming from here. Recognize physical address. So yeah, another thing. One of the pull requests actually had like actually one of the ones I rejected because I thought it was a bit too large. Had like constant names for all these. And at the time when I wrote these in like the second episode where I really wanted to get instructions running, I kind of just threw these in there. But now, already after like a week and a half, I'm looking at these numbers and I'm like, I need to totally put those in constants. So I think I'm actually going to dig into that a bit now. So let's see, where do I want to put this? Oh, we can just put it in here in the main source for now. That'll be all right. So in main, let's do mod memmap and create that file. Cool. We're gonna do so for instance, yeah, so like over here, we actually have the piff from size in the interconnect. That should actually come. Actually, we'll do piff from start. To say U size is going to be 01FC 000. We'll move this piff from size. I'm going to call it piff from length, just because I like that name better right now. And then I like to const piff from end U size is going to be start plus piff from length. And a lot of at least the code in like Sen64 and a couple other things I've seen, they like to have the piff from end be inclusive, so that like the value encoded with this would also be a valid PIF-ROM address. I kind of like to have it where it's exclusive. I mean, if I wanted to conform, I could just do that, but I kind of like doing it this way. So now we can replace these constants at least. Or almost, we need to actually use that thing. Use super memmap. And I'll just import everything from there, because they're all uppercase constants, and they'll won't be ambiguous. So PIF-ROM start. I keep writing state by having start. If it's less than the PIF-ROM end. And then we subtract PIF-ROM start here. The battery's only got like a half an hour remaining. I will keep going until it dies. Oh yeah, we're using U32 for that. I'll keep those as U size. Actually, we'll make those U32s for now. Oh, wait, what? Wait a minute. Oh, this was correct, wasn't it? This is weird now that we got panicked at unrecognized physical address 1FC all the zeros. Did I just write that wrong? What? Is it 1FC0 instead of 01FC? I would not be surprised if I made a stupid mistake like that. At all. Yeah, 1FC0. Well, okay. Cool. Yeah, so now we have the same error, which is good. Yeah, Colin, your banner overlaps the code so we can't see. Oh yeah, sorry about that. It's right up there, isn't it? We'll do that. That should help. That should still be above my face. Let me check. Yeah, that will do. Gotta watch that stuff. Okay, so now that we're looking at this, I also want to look at this stuff. So we had, this in particular was SP status reg here. Like SP status reg like this. That was going to be, what was that? 0404 0010. So I don't want to just check for all these in like a match here because I want to check if it's in the range of those and then match on it. So we want the SP base reg here. And is there... I find it surprising that there's this many registers. It looks like a bunch of these are unused. Oh yeah, see, a ton of these are like the DMEM and IMEM read and write. So that's where a lot of this range comes from here. Yeah, I think what we'll do for now, we'll probably want to, put all these registers in somewhere nicer than this. But I think actually we can just match here. It'll be okay. Let's match adder, and then this becomes the default. Actually, I'll remove the to-do because it's actually fine if it's like this. Yeah, so we want SP status reg. Yeah, I think now we actually start modeling the RSP, which is kind of exciting sounding. And actually, we should probably do this, decoding this is specific inside the RSP code. But let's just start that to get it moving, especially since I don't have a lot of time. Again, really sorry about that, guys. I'll definitely stream later in the week to make up for that. Which I want to do anyway, to be fair. Source main mod RSP. Oh, that's cool. Oh, I didn't open it down here. Actually, let's bring this map back down here and we'll open RSP here. Yeah. So stage register, that was what we were after. Go ahead and open the CP0 stuff because I kind of liked how I modeled that, even though you get a bit cheeky. But let's just do struct RSP first of all. That'll be public. I'm not sure what this is gonna have in it right now. We'll figure it out in a sec. Impl RSP. We need. Yeah. Also, by the way, my keyboard is clickier when I'm in this country because these are actually cherry blues. Love this keyboard, even though it has the funky Norwegian layout. Pub function. What is it going to be called? Yeah. Read status reg. And I want this to, in its later be to do read reg general regs. This will give us a, U32. Yeah. And we'll do to-do on this as well. Because we're not really sure what we're going to do with the bits yet. Skeleton, what keyboard do you actually use? What form factor? This one is a QPad MK80, I believe. Amplify. I thought cherry blues in an office would get you killed. It's not an office, it's my apartment, so that helps. Also, I had it at the office for a while, and they did make me get a new keyboard. Yeah, sorry, losing my train of thought. It's jet lag, man. Okay, yeah, so this will actually do self.rsp.read status ring. And so we actually need to remove some braces here. We need to actually instantiate this RSP. So we'll do, yeah, use super RSP. Probably need anything else beyond that. Yeah, sometimes I like to just order this stuff. So we'll do, we have a PIFROM, and then we have the RSP here. Okay. You might want to box that later, but we'll cross that bridge when we come to it. The RSP is going to be, we'll do RSP new, or perhaps default. I think for now, if we're just going to be returning some dummy data, we can just make this, well, I don't remember the syntax off the top of my head, but it's, you basically make it a unit type. Was it that? I don't think it was that, but it might have been. And then you just type that for actually instantiating it. Probably will tell me if that sucked. Looks like I had a... No, what didn't select? Where did I mess up? Nuclear 36. Oh, it's semicolon here. There we go. Snakker du norsk? Jeg snakker litt norsk når jeg vil, men I don't like to speak it, but I understand it quite a bit. What does PIF stand for? I believe it's peripheral interface. I actually need to look that up myself. There's anatomy of the N64. That looks pretty cool. Console has the PIF, which stands for peripheral interface. So PIF is peripheral interface, which makes sense. I believe you have to go through that to actually like get the controllers and stuff to work. Tokunasu, you speak it pretty well. Thank you. I mean, I sound very American when I speak it, but I am, so. Yeah. So now we had unresolved name RSP. Why was that actually? I'm going to actually also clear the console every time I run this. Man, I'm just totally brain farting on this. Oh, did I call it mod RSP? Yep, I think you're totally right. I believe I didn't do that in main. Oh, I did do that in main. Did I save that? Yes, I did. Huh. That should work then. Menace says Rust? Yes, this is Rust. I totally don't know why I'm not following here. New events, can you export type aliases? Yeah, it may be that I actually can't do that. Could just use a regular struct and put some dummy data in there for now. Let's do that. Dummy. We'll put an underscore in front of it too, which is kind of a cute little cheat that allows you to not have to reference it and have the compiler not complain. We're also going to derive default for this, so then we can instantiate it that way. So then this will be RSP default. Some people like to do default on that. I actually kind of like it where you say the type name. According to the chat, you can totally export type aliases, but because I'm short on time, I kind of just want to, go for it. Now it didn't like that read status reg is not implemented for type RSP. Yeah, that's because I didn't add self here. No, control bus return value, there we go. Okay, so now let's actually look at some of these bits and try to come up with some kind of values that we can return for these. So I'm actually guessing that I can basically return 0 for now. I'd be willing to bet that that's going to be okay. Okay, so by returning 0, we actually did at least get to the next instruction, which is going to be and I. And I think actually this is going to be okay to move forward with just sort of returning 0 like that. Just because, again, I think it's going to be more valuable for us to get through a few more instructions before we start hammering down on the other peripherals. Because they're definitely going to be an endeavor. Ancriox, I'm working on still getting through the boot ROM. Working on mostly the CPU and whatever we have to model to get the CPU to get through the boot ROM. And I'm on 9% battery, so I'm going to have to kill this pretty quick, unfortunately. So episode 4 is going to end up being just super short, guys. Again, I'm sorry about that, but how it goes sometimes. If I stream a lot more regularly, then I don't have to feel as bad. So let's actually look at this. This is and I. Now I believe I already have... Yes, this user manual here. Go ahead and look at this. And immediate. Just kind of what I thought it would be. So let's go ahead and look at decoding that. So let's zoom in on that a little bit. So let's go back to our CPU. And here's our instruction decoding. 1101, this is 1100. It makes sense that and I would be right before OI. 16-bit immediate is 0 extended and combined with the contents of general purpose RS and in a bitwise logical AND operation. The result is stored in general purpose RT. So that's basically going to be copying ORI like this. And instead of OR here, we AND. Yep, that should do it. So let's go ahead and run this. And it looks like we got to the next instruction. So as I suspected, this is going to go a lot faster now. It looks like we got our first branch. That actually worries me a bit. because we're not going to know where that is exactly. But actually, where does this branch to? I believe we can set our base address here. That'll probably help. 1FC000. Apply that base address in our assembler. Does that help at all? I feel like that should do something. Mogminer and Birkenfeld are totally warning me about delay slots. I did also know about those. I've been kind of trying not to mention them. We'll get to those in a second. Rats T2497, welcome, first of all. This is an N64 emulator that we're running in Rust. And I'm on 5% battery, so... yeah, BQZL, yeah, it's going to be right equal to 0. I'm not sure what the L is, so let's actually just look at that really quick. BQZL. I wonder why that didn't actually give us anything. Let's look at something else real quick. Yeah, you guys are saying N64 is supposed to be a pain in the ass to emulate. Yeah, that's part of the reason why I wanted to do it. I wanted to try and live code something that was just really complex that I didn't know a lot about. It's been pretty fun so far. So one of the guys in the chat is saying the Mogminer, I believe it was saying that there's actually different delay slot operation between like BQZ and BQZL. I'm kind of wondering what the difference is there. So I found BQL, not BQZL. Oh, minor, I could be wrong though. Warning, it's just what I call it, yeah. Also, welcome, by the way. I'm the primary maintainer of N64 driver and MAME, says Mogminer. Yeah, really cool. Thanks for joining. Yeah, I'm not seeing that stuff. We get BEQ at least. Oh, likely. I don't know what that stuff is. Looks like branch on equal or 0 likely based on the stuff around it. Yeah, I agree. Ratchet2497 was saying, I once tried to write an emulator for Small 8. I believe you're talking about Chip 8. Which is actually pretty nice for a first emulator to do. Log Miner's given a bunch of hints about how the delay slot is handled, if it's one of the likely instructions or not. In this case, he's saying delay slot is not executed if the condition fails and it's a likely instruction. Really interesting. Yeah, unfortunately, I just hit about 3% battery, so I think I'm going to actually have to cut this short, guys. I'm really sorry about forgetting my charger. This is pretty funny. But hopefully we'll be back sort of same time tomorrow or a little bit earlier, likely a little bit earlier. So again, thank you guys for joining. Unfortunately, this kind of had to happen. But I'll push what little I wrote today and all the stuff I merged and everything. So yeah, let's plan on doing this again tomorrow. And yeah. So really quick, if you guys have any like questions or anything before I go, we do probably have some seconds before everything just dies. Graphene Punk says, same time tomorrow. I would actually like to start a little bit earlier tomorrow. Probably around 6 or 7 p.m. CET. Steal the charger from the person behind you. Yeah, he forgot his too. Amplify, are you doing anything with the SNES sound emulator, or was it just for learning? Actually, in like 2013, I started a tracker for SNES, and if you look up the demo group Elix, I'll find you some links here on Poet. We actually released 2 Super Nintendo demos that I'm quite proud of using that tracker, and that's why I originally wrote that emulator. And then I ported it to Rust as sort of my first Rust project, like my first sort of sizable one. And I kind of want it to be part of like this whole, I want to do lots of emulators thing. So we'll see where that goes. But I would like to do more about that. You know, Colin Smash is really nice. Thank you very much. I was worked quite hard on that, and I would love to actually show you the tech sometime. There's some cool stuff in there. Graphene Punk, I saw your name on a piece of tape stuck to a SNES cart on someone else's video. It must have been Citrix. He's the guy I did the tracker with. New School, ever been to Assembly? I haven't been to Assembly. I've been to the Gathering quite a bit and a lot of other European parties, but I've never been to Assembly. I mentioned the Gathering because it's another big gamer party that has demo scene stuff. But yeah, so it looks like I gotta go. I'm at 1% battery now. So thanks guys for joining me. Yeah, guess I'll see you all tomorrow.